Okay, class, let's continue with this second section, which is numerical sequences or numerical progressions. So what you have to understand here is that we can say sequences or progressions. It's okay. So in mathematics, a progression or a sequence is simply an ordered list of numbers. Ordered list of numbers. What do we call them? Why do we call them progression? Why? It is simply because the list of number progress or move from one term to another. That means if you look at the first term, to obtain the next term, you add a constant value. That's how it goes. That's why you call it progression, because they progress with respect to a constant value. They progress with a constant value. That's why they are progressions. We shall have two types of progressions: arithmetic progression and geometric progression. Let's look at this table where we have the definition of each of the progressions. We have the rule, how to identify whether a progression is arithmetic or geometric, and the formula to calculate any term within the list of terms. That means you have the four or five terms. They ask you to calculate even the 9 term or the 15 terms. How do you do that? You follow this. You use this formula for arithmetic and this formula for geometric. Good. Let's go on. When you talk about arithmetic progression, arithmetic move or arithmetic progress, how do the numbers progress in this case when it is arithmetic? The number progress, look at this. You have 2. To obtain the next, you have 2 and 5. You see that to obtain the next, you have added 3. If you add 3 again to 5, you obtain 8. If you add 3 again, you obtain 11. So they are progressing with adding what? Why adding 3? You can have each term. Now I have given only 5 terms. What if I ask you to give me the 15 terms of this progression? How will you do? You simply apply this formula. It's the same thing with arithmetic geometric progression. See how the terms are 6, 2, 6, 18, 54. How do you obtain this progression? How are they moving? How are they progressing? When you identify that, you will know whether it is geometric or arithmetic. So here, if you divide 6 by 2, you obtain 3. You divide, you take 18, you divide by 6, you obtain 3. Take 54, divide by 18, you still obtain 3. You see that when you divide two consecutive terms, you obtain the same constant, which is 3. So you have a common constant, which is common ratio. The same here, if you divide 9 divided by 3, it give you 3. 27 divided by 9, it give you 3. You see that the number is constant actually. So it's a common constant, which is called common ratio. Good. So we know how to obtain the common difference denoted by D and the common ratio denoted by R. Good. So in case they ask you to identify whether the progression is arithmetic or geometric, take the difference between two consecutive terms. Like 5 minus 2, it gives you 3. 8 minus 5, it gives you 3. When you have the difference, common difference is arithmetic progression. Now if it happen that it does not work with the difference, use that same list of numbers but take the ratio of them. That means you take this one divided you take 6 divided by 2. What you obtain again, you take 18 divided by 6, you see what you obtain. 54 divided by 18, you see what you obtain. If the number is constant all through, it means that it is, since you are doing the ratio and the ratio is constant, it will be common ratio. If you do the difference and the difference is constant all through, it will be common difference. And when they say common difference is arithmetic progression, common ratio is geometric progression. Good. That's how they do it. Now this is the formula how to determine n terms of an arithmetic progression and n term of a geometric progression. Remember, we said having the list of numbers, you have 1, 2, 3, only 4 numbers on the list. What if I ask you the 20th numbers or the 25th number? How will you do? You will not be counting like this. You just use this formula where R is the common ratio, an is the first term, and n is the number on which you want to find. The same thing with this.